Engineering students, come forward, most especially the electrical engineers. In today's tutorial, I will explain the magnetic circuit, the importance, formulas, and relations under the magnetic circuit. A lot of students find it so difficult on this magnetic circuit. What is magnetic circuit? Magnetic circuit is the path where magnetic force flows or magnetic flux it flows. Where magnetic force, or in brackets magnetic flux flows, just like an electric current that passes through an electrical circuit. So let me draw an illustration of magnetic circuit and what? An electric circuit, so that you can differentiate. So magnetic circuit, this is a simple diagram for magnetic circuit. Sorry for my sketch. Magnetic circuit, this is the number of turns. This is the number of turns, and we have the induced voltage of the primary side. And this is a flux. This is a flux. This is a flux. And this is the iron core. This is the iron core. This is a flux. And this is the area. This is the area. So this is the number of turns, number of the primary turns. So this is a small diagram of a simple diagram of what? Of a magnetic circuit. We say magnetic circuit is a path where a magnetic flux flows through the circuit. So this is a magnetic flux. The magnetic flux, it is flowing through what? Through this magnetic circuit. This is the what? This is the iron core, this is the area, and this is the number of turns. We all know number of turns. So this is the number of turns of primary sides, and this is what? And this is the induced EMF of what? Of the primary side of this magnetic circuit. So the difference between electric circuit and magnetic circuit is, this is a magnetic circuit, the flux, it is flowing, and in electric circuit it's something like this. It's something like this. Current, it is flowing, and this is what? This is the resistance. So just like V, it is equals to IR. So this is an electric circuit, but this is what? Magnetic circuit. The correlation between these two. So this is magnetic circuit, and this is what? This is electrical circuits. This is what? A simple magnetic circuit, and this is a simple electric circuit. Electrical circuit. Magnetic circuit, it has main parts. The main parts of what? The main parts of magnetic circuit, we have the magnetic flux, we have the flux, and we have the MMF. We have the MMF, which is what? Which is the magnetomotive force. As you can see, the magnetic flux is the flux that is flowing through what? Through the circuit. Why magnetomotive force? It what? It pushes the magnetic flux. It pushes the what? The flux in what? In a circuit. Why what? Magnetomotive force pushes the flux in what? In the circuit. So in this form, we have two basic relations. We have vector magnetic field and vector magnetic flux density. So the two relation of vector magnetic field and vector magnetic flux density, the relation is the magnetic field intensity, which is equals to mu h. So this is the magnetic flux, and this is the magnetic field. This is the permeability, and this is the magnetic field intensity. And we all know that mu is the same thing as what? Mu naught multiplied by what? By mu r. So this is what? This is a mu naught. And this is what? Mu r, which is what? The relative permeability. So therefore, the magnetic flux should now be equals to mu naught multiplied by mu r multiplied by what? Multiplied by h. Whereby B stands for what? Magnetic flux. Magnetic flux, and whereby the mu naught 4 pi times 10 to negative 7 Henry forward per meter. So this mu naught is the permeability of what? Of free space. Why the mu r is the same thing as what? As the relative permeability. And whereby h is the magnetic field intensity. So what of their unit? The unit of magnetic flux is Henry per meter for the magnetic field intensity, whereby the relative permeability, it is what? It is unitless. It has no unit. So therefore, don't forget with this relation, mu is the same thing as what? The permeability of free space and the relative permeability, and the magnetic flux is the same thing as mu multiplied by what? Mu multiplied by h. And therefore, when you are given the relative permeability, you can use this formula that say magnetic field, which is equals to mu naught multiplied by mu r multiplied by what? Multiplied by h. And then we have the magnetic flux that is passing through a surface. We have the total magnetic flux passing through a surface. So it says the magnetic flux is the same thing as what? The integral of the flux density multiplied by what? Multiplied by the small surface area, which is what? Which is ds. So therefore this and this is a small surface area, and this is a flux density, and this is a what? This is magnetic flux measured in what? And therefore we have the uniform flux formula. The uniform flux formula, which says that the uniform flux formula, which says flux is the same thing as what? At the flux density multiplied by what? Area. The magnetic flux is the same thing as what? Flux density multiplied by area. So if we are going to find what? The flux density, which is the B, we have to divide both sides by what? By A. But before dividing both sides, let's say flux, it is equals to the flux density multiplied by A. So this is another relation that you might use in calculation. So if we are to find the magnetic, the flux density, it is something as flux density multiplied by the area by dividing both sides by the area, which is A, will cancel A, and therefore the flux density, which is equals to flux by what? By area. So this is the uniform flux formula. So let me clean it. The next thing is that the magnetomotive force. As I explained before, magnetomotive force pushes what? Pushes the flux in what? In the magnetic cycle. So magnetomotive force is equals to Ni. So let's say magnetomotive force, and magnetomotive force is the same thing as Ni. Why N is what? N is the number of turns. And I is the current. So this Magnetomotive force, it is just pushes the flux in what? In the magnetic circuit. So we have the reluctance. We have the reluctance. While the reluctance is the same thing as L over mu A. While L stands for the length, so this is the general formula, stands for the length, and therefore A stands for what? For the area. Mu stands for the what? For the permeability. Don't forget that permeability is the same thing as what? Mu naught or mu r. Mu naught, which means the permeability of free space, and y mu r is what? Is the relative permeability. So reluctance, this is the relation of what? Of the reluctance, and y r, let's say r stands for what? For the reluctance. Reluctance is the opposition of what? Of magnetic flux. So reluctance, it is similar to resistance in electric circuit. So let's have another relation. So let's talk about the magnetic field around a straight line. Magnetic field around straight area. So this is straight area. So the magnetic field around a straight area is the same thing as H equals to L over 2 pi D. So don't forget, each and every formula that I read, you have to take note of it. In most of the examples of magnetic circuits, each and every formula that I write, it is very important to you. This relation, all are very important, and this relation, all they are very important. So where the L stands for what? For the length. YH is the magnetic field, and YD stands for what? The distance from wire is what? Distance from wire. So you have to take note, as this distance from wire increases, so now the magnetic field now become weak. As what? As the distance increase, as distance increases, magnetic field becomes weak. So this is magnetic field around straight line. This is the formula that says L over 2 pi D. So there is magnetic flux in magnetic circuit, just like Ohm's law. Let me say magnetic flux in magnetic circuit. The flux, which is equals to what? The number of turns over R. Just like electric circuit, which says that the current is the same thing as what? V over R. But you have to recall that NI, the number of turns, and what? The number of turns and the current is the same thing as MMF, which is Magnetomotive Force. So I can rewrite this as magnetic flux, which is equals to MMF over what? Over R. Let me say magnetic flux is the same thing as MMF over R. So this is another new relation, as well as this. And I just compare this like what? As electric circuit, because Magnetomotive force in in magnetic circuit. So it is just like what? Like electric circuit, whereby I it is equals to V over R. So we have the solenoid magnetic flux density. Let me clean this. Solenoid magnetic flux density also. We have the solenoid magnetic flux density. Guys, if I said solenoid, what is solenoid? A solenoid is not everything but just a coil of wire. A solenoid, it is just a what? It is just a coil of wire. It is just a coil of wire. Let's say this is a coil of wire. Let's say this is the iron core. So solenoid is what? It is just a coil of wire. So the relation of magnetic flux density says as mu Ni by what? By L. This is a very important relation that you have to know. Magnetic flux density of what? Of solenoid. The solenoid magnetic flux density. While the L stands for what? The L stands for the length. Length of what? Length of this solenoid. Of this solenoid. And it is used for what? It is used for long coils. Used for long coils. We have the toroid mean length. So what is toroid mean length? Let me write it here. We have the toroid mean length, which is equals to the length, which is equals to what? 2 pi d naught. Why the d naught stands for the mean. So this formula, it is used in what? It is used to calculate magnetic path length in what? In a toroid. And then also we have the inductance formula. We have the inductance. Let me clean this. We have the inductance formula. Inductance. So, the inductance formula says L over the N flux over what? Over the I. Inductance measures the ability of a coil to store magnetic energy. So, in this point, L stands for what? For the inductance. While N, as we all know, N is the what? N is the number of turns. Why this is what? This is the magnetic flux. Why this is the current. So this is the inductance formula. So after then, we have inductance but using reluctance. So let me clean this. We have inductance using reluctance. So what this relation is trying to show that the L, the inductance, it is equals to what? The number of turns squared divided by the value of what? The value of R. So when the reluctance it is small, so this inductance should now be high. The smaller the reluctance, the higher the inductance. This is what I mean. As we all know, this is the inductance, this is the number of turns, and this is what? This is the reluctance, this is inductance, and this is the number of turns. The higher the inductance, the smaller the what? The reluctance. So let me say this, the higher the inductance, the smaller the reluctance. So we have the Faraday's law. Let me clean the solenoid magnetic flux. We have the Faraday's law, which says that the EMF, which is equal to the number of turns by change in magnetic flux by what? Change in T. So this is the Faraday's the Faraday's law. The Faraday's law, this is the number of turns, this is the change in flux by what? By change in T. So this Faraday's law, what is the Faraday's law trying to show us in this? What work will Faraday's law will do in this magnetic circuit? Faraday's law changing the magnetic flux to produce what? To produce voltage. That's all. That's its use in this magnetic circuit. I need you to know some units. We have flux, we have magnetic flux, we have flux density, and we have mu, and then we have reluctance, we have L. So what will be the unit of this? Because when you are doing a calculation without unit, no answer. No unit, no answer. So yes, I forget with the magnetic field intensity. The magnetic flux is Weber, and Y the flux density is Tesla, and the mu, which is Henry per meter, and the reluctance, which is ampere per wave. This is wave, yes, Weber, and this is Henry, and this is ampere per ampere per meter. So here are the some values with their units that you supposed to know, guys. So this is all I have for you for today. Don't forget to subscribe to this YouTube channel, and this topic, it is very important, magnetic circuit. Don't forget with the formulas, each and every formula that I write, you're supposed to jot it down, because it is very important. This topic, it is very important, very, very, very important. Don't forget to subscribe. Thanks for watching.